Hi everyone, happy Monday. I am going to present to you all your mini lesson for today and tomorrow, which is Tuesday, so April 20th to April 21st. This is your first lesson. It's probably going to be a little longer and it will probably take you a little bit more time to complete. And that is fine because again, you have 2 days to do this. So I have my agenda here for today. Our first thing on the agenda that you should have already completed is your do now, just something to kind of get you warmed up for today's lesson. And now we are at our video lesson and slides. So I will go through a series of slides, and throughout the videos, you will also complete questions. You'll have to answer some questions before you can even move on throughout the whole entire video. The third thing on the agenda is after this, you will go back into Google Classroom and you will complete your vocabulary document where I will be going through like definitions and things like that, and just words that we'll be using throughout the next few weeks. You'll also have your independent practice after that. That is also in a both days will be in a Google document, so you will have to submit your answers in a Google document, and then you have your exit ticket. Okay, make sure you go through each from beginning to end. It is essential. Okay, like you cannot complete the independent practice without watching the video lessons and slides. So our standards for the next week or so will be EEB5, so expressions and equations. You graph, and EEB5 is what we've been working on for some time now. So graphing proportional relationships, interpreting the unit rate as the slope of a graph. We're comparing two different proportional relationships represented in different ways. So for example, compare a distance time graph to a distance time equation to determine which of the two are moving objects are moving at a greater speed. That's something we still need that standard to complete our next standard, which is EEC 8A. And the A, there are different parts. So there's A, B, C. The first one that we're beginning is AA. So we're analyze and solve pairs of simultaneous linear equations. And again, like we'll get into that in greater detail. This is specifically understand that solutions to a system of two linear equations and two variables correspond to points of intersection of their graphs, because points of intersection satisfy both equations simultaneously. So again, we'll get into this in much greater detail. Our objectives for today we will all be able to conclude that a system of linear equations, also known as simultaneous equations, is when two or more equations are involved in the same problem and work must be completed on them simultaneously. So together, we have to work with them together. Our second objective for today will be able to identify the notation for simultaneous equations. And our third thing on the agenda is we'll be able to compare graphs that comprise a system of linear equations in the context of constant rates to answer questions about time and distance. So again, we're moving towards real world problems before we actually look at systems of equations. So I know we've been doing this for like before spring break, we were doing this for some time, but I'm going to take it a step back and we're just going to kind of start fresh. And we're going to start with word problems, real life problems. So introduction to simultaneous equations. Simultaneous equations are two equations, each with the same two unknowns, and are simultaneous because they are solved together. So you need both equations to solve whatever problem it is that we might be focused on. Okay. So our vocabulary for today, and you'll be seeing this a lot. Like I really want to just review so that you are aware of what we're working with. You're gonna hear me say equation, simultaneous equations, systems of equations, solutions, coordinate plane, or coordinate grid. I might use it differently, but they're the same thing. Graph, coordinate point, ordered pair, which is it's the same thing. So I'll use one or the other, but I just want to put it out there so that you're familiar. And values. Solutions. Yep. So an equation is a statement that the values of two mathematical expressions are equal. So an equation separates two expressions with an equal sign, right? And that is a mathematical statement that tells me that two expressions are equal. Right? So now we have